Okay, so in this video lesson, we're still looking at class frequency distributions, but we're looking into some further details of a class frequency distribution. So you can see that this is still part of a section 2.2. Okay, so now that you have constructed for yourself a class frequency distribution, and specifically if we're looking at data 1, for example, you can refer back to the other video where we looked at the class frequency distributions. So for the same class frequency distributions, here's what happens. So we have a class from 60 to 69. We have another class from 70 to 79. We have another class from 80 to 89. So these are, and hence and so forth. And so now, if you look at each of these classes, now each of the class here, if you look at the anatomy of each class, it contains two numbers. And each of those numbers, we call them the limits. And more specifically, the lower number, we call that the lower limit of a class. Okay, and the higher number, the higher value there of the interval, we call that the upper limit. Okay, so now if you can see again here, I'm looking at lower limit, okay, and that is the upper limit. Alright, so now as you can see, any class would have any class in a class frequency distribution table we have a lower limit and an upper limit. Okay, so that's the idea of looking at limits. Okay, that's what we're looking at, limits. So now the next concept that we're looking at here in a class frequency distribution table here is we're looking at class boundaries. Okay, now class boundaries are not to be confused with the upper and lower limits. Now, class boundary is defined to be the dividing line between any two classes. So if you look at data set 1 again, and here are the classes that we consider earlier in the other videos. So these are the classes. Once again. Okay, so these are the classes. Now, class boundaries, I'm talking about those values exist in between and acting as the dividing line for between any of these two classes. So now, specifically for that, for the first two classes, the dividing line, or we call it formally the class boundary between these two classes, would be, you take the 70 here, add that together with 69, which is the upper limits from the lower class, and we divide it by 2. So that's what we always do. And so now the class boundary for between these two classes would be 69.5. And then likewise, here's my dividing line right here. And you can notice in the way how we construct our frequency distributions earlier. Now, between any two classes, there are some kind of gaps in between the upper limits and the lower limits for of the two classes. So that's why we have to find the class boundaries. And so now the dividing line here between these two classes would be 80 plus 79, and we divide it by 2, and so that class boundary would be 79.5. And then once again, you can see right here we have 90 plus 89 divided by 2, and that gives me 89.5. Now, if you keep continuing doing this, you're gonna find the rest of all the other class boundaries. Now, make sure. Now, your very last class would be the one from 110 to 100. Actually, I got it. 120 to 129. Now, this last class you do not have to worry about, so there would be no boundary here. No boundary there, because we just simply don't have to find a class boundary beyond this class, because we have no more class above that final class right here, and likewise we would have no boundary here. We don't have to worry about it doesn't mean that we don't. It doesn't mean that we have no boundary really, but we don't have to worry about finding the boundaries on the two ends right here, like under the first class and above the last class. So you only have to find the class boundaries between these classes on the list. Okay, so that's how we can find the class boundaries. Now, another term in the class frequency distribution is so-called a class midpoint. Okay, so now here are our classes, 60 to 69, and we have another class from 70 to 79, and here I have another class from 80 to 89, and these are the classes. Now I'm not gonna go through the whole list of all the classes here, but to find the midpoints, all you have to do is look at each class here, and we add the lower limits to the upper limits, and we divide it by 2. So here I have 60 plus 69, and we divide it by 2. That is my midpoint for the class, for this particular class. So that would give me 64.5, and here I would need to do 70 plus 79 and divide it by 2, and that would be 74.5. And then you can see that the next one here, quickly calculated, that can give me 84.5, and here I have 94.5 and so forth. So the idea, the reason I'm calling them the class midpoint is just because these values here exist right in the middle of each class. So here 74.5 is right in the middle of my class, even though each of these midpoints don't necessarily belong to the class themselves. The next thing that you would want to know in the class frequency distributions is what's so-called a class width. Now, if you notice, if you look at each class once again, 70 to 79, and here I have 80 to 89, 90 to 99, and I have 100 to 109, I have 110 to 119, and here I have 120 to 129. Now, before I get started with this, so these are the classes. Once again, these are the classes back in the frequency distribution for data 1. Now, I have to make it clear, I have to clarify that each of these little sign in between the class here, now those, please do not confuse them with the minus sign. These are just hyphenations. They are indicating that here in this class I have numbers ranging from 60 to 69. So when you hear the term class width, you might rushly think that it's just simply 69 minus 60, but however, that's not the case here. Now, to find the class width, really what you're doing is you're gonna take the lower limits in the, say, if you want to find the class width for this particular class, for example, now you're gonna have to subtract the lower limits of this class from the lower limits of the upper class, and that's what I do. And so that gives me equals 10. So 10 is my class width for this particular class. So once again, let me repeat. To find the class width for a particular class, what you need to do is you subtract the lower limits of that particular class from the lower limits of the higher class, and then that gives you the class width. Now the higher class, what I mean is the one right above it. And so now moving over to this class right here, this next class right now, the class width would be, you're going to have to do 70, which is the lower class for this current class, the lower limits for that closing class, that current class. You subtract that lower limits from 80, which is the lower limits of the higher class, of the upper class, of the class right above it. And so here we have 10 again. And so now continuing with this fashion here, I'm going to have 90 subtract 80, and that gives me 10 again. So 10 is the class width for this particular class. And now I can, as you can start seeing the pattern of the work here, I can skip all that doing math work, and now my class width here is going to be a 10 again, and here's a 10, there's a 10 for my class width, and there's a 10 for my class width here, and that's how we find class width. Now, the last detail, the last idea that I would like to mention in a class distribution is, now the last concern actually. So if you notice in my class width, in this case, if you notice from what I calculated for the class width here, you can see that every single class here I have the same width, 10. Now, so we want to add in a little remark here, but actually that for this class that we're learning, for this class, okay, I mean, I'm not talking about each of these, I'm talking about our statistic class here. We will use equal class width. Okay, so that's the bottom line. So I mean, there are cases out there where you have to run into different class widths, but here we will just simply use equal class width. So that's one convention for us here in this class. Now, next convention here is, if you already took a look at the class distributions just earlier, you can see that the class width were all 10 all over, and it has been chosen to be 10. So now, you might wonder, must it always be class width 10? Okay, so that's the one of the question that might be addressed out there. Must it always be always be class width 10? And the answer is a straight no. And so I'm going to show you the idea now. When you are doing your real work, your actual work in statistics, you have to decide a class width for yourself. And here, so let's try to reinvestigate everything. What happens if in the same data set, okay, but we do class width? What happens if we do class width 5, for example? So now here's observe what's going to happen. I'm going to reconstruct a similar table. So here on this column I'm going to list all the classes, but this time I'm going to do class width 5. So here my lowest value is 60, so I'm going to go 60 to 64, and then I have 65 to 69, and then I'll have 70 to 74, and then I'll have 75 to 79. I have 80 to 84. I'll have 85 to 89. I'll have 90 to 94. And you can see that now at this time, I mean, decreasing our class width right here, making our class width smaller, is going to produce much more classes for us here to draw. And so here we have, I'm going to have more classes to go, 95 to 99, and I'll have 100 to 104, 105 to 109, I'll have 110 to 114, I will have 115 to 119, and I'll have 120 to 124. So I will have much more classes. But here what you can see is I don't even have to worry, I don't even have to bother with 125 to 129. So what's the reason? I mean, technically you can, but what's the reason? My last data value is ending up at 124, so I can safely or legitimately stop at 124. I mean, in the class between 120 and 124, and we can skip all this final one right here. But look at how many classes we have now. So generally I can see that less class width, okay, means the same thing as more classes. Okay, and I'm going to generalize all this idea again as we get into the visual display of a class frequency distribution and what's so called a histogram.